Okay, so let's give you guys some more practice. So here, find the linearization of f of x equals 1 plus x to the power 3 at x equals 0 here. So me asking you to find the linearization of this red line here is the same as me asking you to find out the equation of the tangent line passing through this precise point here. So you're going to need the gradient at this point, and you're going to need the precise location, the precise coordinates at this point here. So it will be 0, comma, and then put the 0 into this whole thing here to give you this y here. Okay. Well, anyway, find the linearization of the red line here at x equals 0. As a clue, um, the equation, your tangent line, if you like, is given by this here. Well, anyway, find it out. So press pause and have a go. Okay, so to do this here, hang on. So to do this here, we're going to need the gradient of this line at x equals 0. So we're going to need to differentiate this. So our first step is to differentiate this. Okay, so start out with f of x equals this thing here. Differentiate it. It will then give you this. But then we need to know the gradient at x equals 0. So the gradient at x equals 0, we're going to need to put 0 into this, into here. We're going to need to put 0 into here. Okay, so the gradient at x equals 0 is given by this, which is 3. Okay, so now looking back at our equation here, it would be L of x equals, well, this thing plus this thing times this thing here. Well, don't forget this bit here represents the gradient at x equals 0. So we just worked it out to be 3. So we can put this 3 into this block here. That will then give us this. Okay, 3. So that's this block here, and x minus 0 here. X minus 0 is just x, and then this block here is really f of x at f of 0. So the normal f of 0 is actually 1, because if you look at this here, if you put 0 into this thing here, then the height here will be 1. Okay, so going back to here, hang on. So from here, well, we just worked out that the gradient at x equals 0 is given by 3, so we can put it into here, and then this here is 1. So the equation of our straight line is given by this. So if you get a graph plotter and plot it, it will look like this. You see, around near 0, near x equals 0, around here, our linearization is a good approximation to our red line here. So our blue line is a good approximation to our red line. But the thing is, the red line is a lot more complicated than the equation for the blue line. So the point is that around this region here, the blue line is a good approximation to the red line.